Good afternoon. Today we are talking about prime factorization. It's kind of like Factor Ninja meets Optimus Prime. Let's get started. Today we are going to answer the questions, what is prime factorization and what are the methods for finding it? Well, it's actually pretty simple. Prime factorization means that we break a number down into factors so small that they're all prime numbers. So, let's take a look at these three numbers. They can be pretty small, like 6. So if I wanted to do 6, whoops, I'm going to draw my little factor tree action here. And if I wanted to multiply and get 6, well, I don't want to do 6 times 1 because that doesn't really do me any good. But if I do 3 times 2, well, these are both factors and they're both prime numbers. I couldn't break this down any smaller if I wanted to. So the prime factorization of 6 is 3 times 2, and I would write that out, 3 times 2. Simple enough, but let's try a bigger number. I'm going to show you something real cool in a second too. 12, okay. I could start by doing 4 times 3. Those are factors of 12. Well, 3 is already prime, so that's done, but 4 is not a prime number, it's composite. And I make 4 by multiplying 2 times 2. And 2 is a prime number, so I'm done. And to do the prime factorization of 12, I would do 2 times 2 times 3, except that you know your exponents. So this actually would be 2 to the second power times 3, done correctly. Let's take a look at 17, and then I'm going to come back and show you something. All right, 17 is really easy. Why? Well, its only factors are 1 and 17. Those numbers are both, well, that's not prime. I can't say they're both prime because 17 is prime. 1 is emerp. Either way, it can't be broken down anymore, and the prime factorization of 17 is 1 times 17. So here's the cool thing I wanted to show you. A minute ago, I did the prime factorization of 12, and I started with 4 times 3. And when I was done, I got 2 to the second power times 3 as the prime factorization. Don't believe me? Back up the video, you can see. But you know that there's more than one way to multiply and get 12. You can do 4 times 3, but you can also do 6 times 2. What happens if I do it a different way? Well, let's take 6 and 2. Okay, 2's prime, so that one's done. And then to make 6, because it's composite, we do 3 times 2. And those are both prime. So I also have 2 times 2 times 3, which is the same as 2 to the second power times 3. The exact same thing I got when I did 4 times 3. Interesting, huh? So it doesn't matter if I'm doing a larger number how I do it, because in the end I'm going to end up in the same place. Now your textbook shows a second method of finding a prime factorization. It does the same thing, it just looks different. Okay, this time we're going to look at the number 6 and ask ourselves, what's the smallest prime number by which I can divide 6? Well, any number that's even can be divided by 2, and there isn't a smaller prime number than 2. So if I divide 6 by 2, I get 3. And guess what? They're both prime. So that one's done. And the prime factorization of 6, you already know, is 2 times 3. So this time again, we're looking at the prime factorization of 12. And on my T-chart, there's my 12 ready to go. And this time, it needs to be done in a certain order. So I'm going to ask myself again, what's the smallest prime number by which I can divide 12? Well, that's 2. So I'm going to put my 2 here. And when I divide 12 by 2, I get 6. Okay, 6 is composite, so I got to keep going. What's the smallest prime number by which I can divide 6? 2, and then 2 times 3. And these are all primes, so I'm done. So here's again, for the third time, you should be getting good at 12 by now. 2 times 2 times 3. And then, so 2 to the second power times 3 is the prime factorization of 12. And then 17's, again, easy peasy. What's the smallest prime number by which I can divide 17? Well, 17. 1 prime, 1 emerp, but it's too small to do anything else with, so there we go. And there are prime factorizations done a slightly different way. So let's try some examples here. I'm going to let you give these a shot, and then we'll go ahead and check. So stop the video. I don't care if you use a factor tree or if you use a T-chart. That's totally up to you, although any teacher is going to look at that and go, what the heck is that? But that's okay. So go ahead and knock these two out, and then we'll check. So there are two different ways of doing 18. I'm going to use factor trees. Why? Because that's what I'm good at. So, but I'm going to do it both ways for you. Okay. One way to do 18 is 2 times 9. 2 is prime. 9 is composite. How can I make 9? 3 and 3. And those are both prime numbers. So the prime factorization is 3 times 3 times 2, or done more properly for your age, 3 to the second power, because there are 2 of them, times 2. Okay, so that's one way of doing 18. The other way is to do 3 times 6. So let's take our 3 and our 6. Okay, 3 is prime, so that's good to go. 6 is composite, so also 3 times 2. Whoop, come on, 2. There we go. And these are both prime. So just like when I did 2 times 9, I end up with 3 to the second power times 2. Didn't matter whether I did 2 times 9 or 3 times 6, I ended up the same place. All right, let's take a look at 27 then. There's really only one way of getting there, because that's 3 times 9. 3 is prime, 9 is composite. So let's fix up 9 here. And that's 3 and 3. And those are prime. So we end up with 3 times 3 times 3, or 3 to the third power. And that's all done. You've got 4 more examples in your notebook for you to work. Those will become your quiz over to the right. But for now, we have answered the questions. What is prime factorization? Well, that's when you take a number and break it down into its factors that are so small that they're all prime. What are the methods for finding it? Factor trees are what's comfortable for a lot of people because that's the way we got taught, but there's also a T-chart method that you're welcome to try. So, get back those examples in your notebook. Have an awesome evening, and I will see you tomorrow.